Alright, today we're going to be talking about Docker. Alright, let's jump right in. So, what is it? Docker is an open source platform designed to automate the deployment, scaling, and management of applications. Okay, so first of all, let's talk about deployment. So, deployment essentially comes down to putting code in production environment for customer use. So, here's a really handy chart to kind of help us envision this, right? So, software engineers are at the left side of this chart here, right? They deal with branches, they deal with GitHub with version control, create their features, iterate over, and then create the pull requests, right? And then once that gets peer reviewed, it gets tested, and then it gets sent over to production. And this part right here to the right is where we deal with the deployment. This is where people actually put their code in servers to be pinged by users. So whenever you go to google.com, amazon.com, that hits their production servers. And, like I mentioned, this left part of the chart here has to do more with software engineering. And this right part starts to kind of dive into um, DevOps, which means development operations, in which, like I said, those things have to do with how can I get the software that has been created by the software engineers here to the left and make it available to millions of people, right? As a software engineer, you usually concern yourself with how can I make this run on my machine, make it do what I want it to do, and then make sure that it doesn't have any bugs. Like I said, part of the right chart here is to make sure that you can take that software and make it available to millions, if not billions, of people, right? So that's what we talk about when we talk about deployment. So that entire practice, how do we do that? Where do we put it? How do we make it available? How do we load balance it? Things like that. Scaling. Scaling is also a very, very interesting subject, right? So if we have a spike whenever people are using the application, how do we add more servers? This is what scaling deals with, right? So we have another little chart here that's very useful. So this chart right here is the visitors that go to Amazon.com for about a year here, from February 2018 to April of 2019. As you can see, this isn't a straight line. It goes up and then it goes down, and it probably peaks around Christmas, right? So as a DevOps, not as a software engineer, because you don't concern yourself with this, how do you make sure that you understand that sometimes you're not going to have that many users, and sometimes, like during Christmas or during July, during summer, there are going to be more people that want to use your software. So that is what scaling concerns itself with. And management. How can I add more servers? How can I scale up and scale down? How can I monitor all my systems, all my servers? How can I control the resources? How can I add memory, remove memory, things like that? So that is what Docker aims to try and do, and this is an open source platform designed to help you with all of these things. Again, Docker more concerns itself with the development operations part of software and not necessarily software engineering. Um, and it uses this term called containerization technology to bundle an application and its dependencies in a single object. So let's talk about containerization. What is that? The term itself comes from ship containers, as we can see from this picture here. So as you can see from this picture here, you have a boat, and in every single one of these containers, you probably have things that are completely different from the container above it or next to it, and that does not matter, and that's the whole point of this, right? So in one of these containers, you may have toys. In the next, you may have chairs. In the next, you may have books. And that doesn't matter. What matters is that you are able to put all these things in a ship and ship it. And that's essentially where the term comes from. As you will see later when I start to talk about how Docker works and how this is going to make more sense once I kind of go into that. Let's see here, and this is the Docker logo, as I kind of showed you here before. It's kind of the same thing. This is the Docker logo, and it's this little whale that kind of has containers on top of it. So let's see here. So who created Docker? So it was created by a company called Docker Inc., which is founded by some guy named Solomon, Sebastian, and a few other people. But again, it is used by developers and system admins or DevOps who need to create, deploy, and run applications across different environments. And this is key here, right? So again, like I had mentioned previously, the entire discipline post software creation is called DevOps, or which is short for development operations, or some companies call it infrastructure. For my experience, more and more of this is being merged into the SWE role. So, as a software engineer, as we go to this chart here, software engineers are used to only be concerned with the development and the peer review. As time has gone on, they're also in charge for testing their own stuff. And as time still has progressed, software engineers are expected these days to kind of understand the entire flow from from creating the code to testing it yourself to peer reviewing to the production environment and the development operations. So that's why this is important, and that is who created it and why they created it. So when this was released about 10 years ago now, and it offered a model of virtualization, that's a big word, that quickly gained popularity in the tech industry and open source community. So let's talk about virtualization. This is very important. So let's look at the actual, or one of the definitions that's very, very close to it. So containerization, unlike traditional virtualization, where each application runs on its own virtual machine with a full operating system, containerization allows multiple applications to share the same operating system kernel, which makes containers more lightweight and faster to start than virtual machines. Okay, that was quite a bit. So let's take a look at this chart to understand what it means. So on the left here, this is what used to happen. This is a virtual machine, right? So this app one, you can imagine, is something like a Flask app or like a Rails app or a React app. That sits on top of all of the libraries that make it work and its own operating system. So back then, if you wanted to boot up some sort of application um, on a server, you needed to create a virtual machine, and each virtual machine comes with its operating system. This operating system could be Macintosh, could be Windows, could be Ubuntu, could be Linux, could be whatever you want. So this is how it used to be, and starting each of these up took quite a while. And like we had mentioned before, if you are trying to scale up or scale down to add more servers, you want to be able to add the servers right away so that your users don't encounter latency. You want to be able to say, hey, we need more servers, and it's going to take a second to boot up 100 of them versus this may take 5 minutes, 10 minutes, maybe even more. On the right here, we have containers. Containers all utilize the same operating system, which is key, right? So you have this container engine, which is your Docker runtime, and you have apps that run on top of that, right? So you have your Flask, you have your Rails, you have your Nginx, you have your caching, you have your Redis, whatever you want. And because of this architectural style, you can boot these up in seconds, and you can boot up hundreds of them in seconds. So this makes it a lot more clean, and now you can kind of start to see the container analogy that we have here, right? So we have these apps that kind of sit on the container engine, which is, you can look at the container engine as the boat, and you just put containers on top of it, right? So containers run within apps. So that's the main difference between virtual machines and containers. I think that the main takeaway that you have to take from this is that virtual machines are not as lightweight as containers. They take longer to boot up, they take more resources, and are therefore going to be slower to boot up, as opposed to containers, which are a lot faster to boot up and take up less resources. And you could even control the resources into these different apps within the container engine. You can say, hey, give more memory to app one or less memory to app two, whatever you want. So that is the virtualization aspect. Okay, so where would we want to use Docker? You could use it, anywhere where you have a computer, from your own personal computer to a high-end server in whatever data center, in Amazon Web Services, in Google Cloud, in Azure. One of the key things about this is that it's platform independent. It can run anywhere, anywhere. All you have to do is install Docker, which we had shown here before. All you need is this container engine, this green thing right here, and you can install that anywhere, right? So you can run this, you could run this, like I said, anywhere, whether you're on Windows, whether you're on Linux, whether you're on CentOS, Red Hat, Ubuntu, whatever you're running. Yes, as long as you have the Docker operating system, you can run any Docker application. So why is that important? Because it simplifies software development. How does it do that? It also simplifies testing and troubleshooting by creating a uniform environment across systems. So, what does this mean? It means that if you are developing software with a team of people, and everybody on the team has a different laptop, a different, or they have a different laptop, they have a different operating system, or say that you even get them all the same laptop, they may still have a different operating system. Say that you get them all the same operating system, they may have a different version of that operating system. And what happens a lot of the times is that you create your software, you write your software, and then you pull the branch down and you say, hey, my branch works on my machine, but it's not working on yours. And that is a very common problem that software engineers face. This helps alleviate a lot of that um, because it all runs again on that little green line that I had showed you all before. All you need is this green line, and you can put it anywhere. If your friend, if your coworker has another operating system, if they have another machine, if they are running on a phone, whatever, as long as they have this container engine, they are going to see the exact same thing that you are, and that has helped software engineering a lot, which brings us back to why this thing is so popular, right? Um, let's see here. So with this simple interface, we could run anything across any platform. And this is what the interface looks like. You go to your terminal, whether you're on Windows, whether you're on Mac, whether you're on CentOS, whether you're on Red Hat, whether you're on whatever. And with these commands, you can start up any application. Like I said, whether it's Flask, whether it's Ruby, whether it's a Python thing, whether it's whatever application you are working on, you can run any application and you can spin it up very quickly by using these particular commands. Okay? So again, it allows developers to package an application with all of its dependencies into a unit. And this goes back to um, this particular picture that we saw. Like each of these is a single unit. Think of these containers as your app. This container has every dependency, anything that your application needs, and you can run it on the Docker system with whatever machine you are using, and it's gonna work across any operating system, across any machine, across any server, as long as again you have that same container engine, all right, which is gonna alleviate lots of bugs, like I had said. Let's see here. Where was I? So that is the what, the who, the when, the where, and the why of Docker. So let's go over some key concepts here. Again, containerization. Unlike traditional virtualization, where again you have to spin up an operating system for every single application, each application runs on its own virtual machine with a full operating system. Containerization, on the other hand, allows multiple applications to share the same operating system kernel, right? So again, we go back here. So all of these applications share this operating system, which again makes it faster to stand up. And we could scale up or down a lot faster than having to build up an entire operating system just for an application. Let's see. In Docker, an image is a lightweight, standalone executable package that includes everything needed to run a piece of software, including the code, runtime, libraries, environment variables, configuration files. Images are read-only and never change. Okay, so images are another very important concept, right? So um, let's talk about containers because they go hand in hand with images basically. A container is a runtime instance of a Docker image. So you can think of an image as a class and a container as an instance of that class. Containers can be created, started, stopped, moved, or deleted using the Docker API. So essentially, an image describes um, our application, right? An image has all the necessary information for running Python, for running Ruby, for running any single application that you can think about. The image has the information to be able to execute that. A container is when you actually say, hey, I want to run this image on my machine. And once you run that, then all of a sudden you have a way to interact with Ruby, with Python, with React, with Flask, with any application that you can think about. So again, the container is the actual running instance of an image. Again, I think that this metaphor is super, super helpful. You can think of an image as a class or the blueprint. And once you bring that to life, then you have essentially a container that is running whatever application that you can think about, whether it's a database, like I said, whether it's a web app, whether it's an instance of Ruby or of whatever programming language you can think about, right? And all of this is done through a Docker file. A Docker file is simply a text file that contains everything that you need to create an image. So let's take a look at this particular chart here, right? So from a Docker file is where we go in there and we say, hey, we need the operating system, Mac, right? And we want to run Flask. And we also need to get Python. All of these things, whatever you want, whatever application you want to build, essentially, you put it in your Docker file. You execute this particular Docker file and you get a Docker image. And once you run the Docker image, then you have your container, right? And you can interact with this container. You can ping this container and say that your container is running Python. You can ping this container and run Python code. Or you could run a Docker container that is running Flask with some code that you created to create whatever application you want. And if you ping this Docker container, you're going to get a response. So that is the Docker file, the Docker image, and the Docker container. Docker Compose is essentially a more complicated Docker file that uses YAML to be able to manage multi-container Docker applications, right? So say that you have an application that requires a database and the web app talks to this database. Now you can have two containers, one that runs your web app and one that runs your database. And how they communicate with each other is what Docker Compose concerns itself with, right? Let's see here. And another term that we want to talk about is the Docker Hub. So Docker Hub is a registry where Docker users and partners create, test, and store and distribute container images. You can think of Docker Hub just like GitHub. In the same way that you as an engineer create code and you push it to GitHub and another person can pull it down and mess with it, the same thing with Docker. Say that you want to create whatever application that you can think of. You can create a Docker file for it, build an image for it. You can push that up to Docker Hub, and then I can pull the image down, run it, and then I will have a container running the application that you created within seconds. Because again, when you run a container, it's a lot faster than a virtual machine. So that is what Docker Hub is. And again, if we go to Docker Hub, we can see what it looks like. It looks a lot like GitHub. And these are all of the images that we could run, right? So we can pull any of these images right now. I am running Mac, right? I am using this on a Macintosh. But I can run Ubuntu on my Macintosh if I want, which is an operating system. I can run Alpine, which is another operating system. I can run Python, Redis, Postgres. I can do all these things within seconds if I pull this down and run it locally. Traditionally, before Docker, what you would have to do is you would have to create a virtual machine, go to some place and get Alpine, and you had to run it, and it would take minutes, if not like 10, 15, 20 minutes just to stand up. Again, now I can do this within seconds. And the most beautiful part, again, of all of this is that you have access to all these things and you can run them locally. But again, you can run whatever application you're working with your friends, with your company, with your whether you're working within a company, whether you're working as a team with a group of people in college. You can all like work on the same image and you could all pull it down, and wherever you are working on, again, whether one of them has a Windows machine, whether one of them has a Mac, that doesn't matter. It's going to work as long as you have Docker installed, which again, removed a lot of the bugs that you used to have when people were saying, hey, well, it works on my machine, but not on that one or not on this one. Now you remove all of that completely. You remove all of those variables. And now you could just come to, Docker Hub and pull whatever image you want and then run it locally. And all of a sudden, you're going to have whatever software you want running in a container um, within your sorry, I'm trying to go back to, I think it was this one, virtualization. This one, maybe, yeah, this one. As long as you have this container engine, again, you are able to run any of the applications that are listed here. All of these are just applications. Like here, watch. App 1, App 2, App 3. Any of those could be these WordPress, PHP, console, whatever you're looking for, right? SonarQube, Ruby, Elasticsearch, Tomcat, any piece of software, you can package it up and put it on top of your container engine and just run it. Again, you're going to be sharing the resources of one operating system, and this operating system does not matter. What matters is this container engine. As long as you can put this container engine on top of Windows, Mac, Linux, CentOS, Alpine, anything, then your applications are going to run and they're going to look exactly the same as your partner who has a different operating system. Yeah, so that is Docker. Again, the key takeaways is that this mainly concerns itself with DevOps, deployment, scaling, and management of applications, not necessarily the software engineering portion, right? Which traditionally could be seen as just this part. Now you're kind of getting into like, how can I put this out there for people to ping? And again, one of the reasons why it's so important is because when you talk about scaling here, when you need more servers to be able to handle this spike or this giant spike, you want to be able to respond and create more servers as fast as possible. And this gives you a way to go ahead and do that, right? Because like we discussed, this is not as heavyweight as virtual machines, right? And another benefit that you get, just to kind of close up here, is that you can package up applications and send them to Docker Hub or to whatever hub you can store your images, and other fellow developers can pull that down and work on it. And it's going to work just the same with whatever operating system they are working on. Okay, that was a quick overview into Docker. Like and subscribe, I guess.